In your last video and in your last lesson, we did an investigation to see how you could take our simplest parabola, which is y equals x squared, and create new parabolas with it just by applying some adaptations to it. And I'd just like to summarize what some of those key findings should have been. So in the first page of your investigation, we played around with this a value. And we played around with it in a couple of ways. First of all, we looked at whether it was positive or whether it was negative. And we came to the conclusion that if it's a positive value, it results in an upward facing parabola, or I like to call it a happy face. It's happy, it's positive. And if it has a negative value, it turns into a downward facing parabola, or I like to call it a sad face. So the sign of A is really important in understanding a little bit about the behavior of a given parabola. The other thing we looked at with respect to A is what if it is bigger than 1 or bigger than our y equals x squared base parabola where the value is a 1. And we realized that when we put a 2 or a 3 or a really large number, what it ends up doing is it ends up making the parabola narrower and narrower closer to its axis of symmetry. So when A is bigger than 1, we call this a stretch factor. And when A is less than 1, so anywhere from 0 to 1, it could be a fraction, it could be a decimal, you saw through the investigation that that causes the parabola to widen out as opposed to being very narrow or stretched up. We call this the compression factor. So just by looking at this value in front of the x squared term, we can already realize with respect to x squared a little bit about the shape and the direction of opening of this particular parabola that you're looking at. We also then tried subtracting or adding some values to x before doing the squared function. And this I want to talk about specifically. If h is a positive value, what that means is that when you sub in h, you're going to get x minus and a positive h value. So say plus 3. But because of these double signs, what you're actually going to see is x minus h. And we noticed that when we had x minus 1, x minus 2, x minus whatever squared, in essence, this ended up shifting the whole parabola to the right, which we thought was counterintuitive because when we see a negative, we think to the left. But when you realize that what you see is a result of substitution and simplifying signs, it really does suit that having a positive h value means that you're going to shift or add to x before it's squared, moving it to the right. In a similar fashion, if h is a negative value, when we sub in that negative value into x minus, we will have x minus negative h. Well, when you, and I'll put the squareds around here too, just for clarification. When you simplify these signs, what are you actually going to see? Well, you're going to see x plus some h value squared. And we realized that when we saw this, if we saw x plus 1, or we saw x plus 2, or x whatever, it actually shifted the whole parabola to the left. And again, you go, but it's positive. Why is it shifting it to the left? Well, it's positive overall because h was negative. So h being negative and shifting to the left actually coincides with what we already understand to be left and right and positive and negative according to the x-axis. We know that when we have 0, when we have positive numbers this way and negative numbers this way, the positive means to the right and negative means to the left. It's just because we sub it in and there's a negative sign here that it changes what we actually see. So that's the trickiest transformation of the 3 to predict. I want you to pay special attention to that one as we move forward. Lastly, we looked at what happens to a parabola if we square x, but then we add k, or we add something to it. So again, if k is positive, that means we're going to have x squared plus a positive k value. Well, these two signs will result in us just seeing x squared plus k. So a positive k means we're going to take that entire parabola and shift it upward along its axis of symmetry. Okay, so that's kind of nice because what you see in terms of sides corresponds with what you know positive to be in terms of the y-axis. You know that the positive region of y is up in here and the negative region is down in here. Okay? So in a similar fashion, if k is negative, what does that do to the x or the y equals x squared parabola? Well, if we have a negative value of k, we're going to see it as x squared, and then we're going to put in our negative k value. And again, that's nice because what we see is what we get. This is going to take our entire parabola and shift it down its axis of symmetry. So it's super important to understand these individually first before moving on to this next lesson, because now what we want to do is we want to combine these ideas all together. So watch how we can do that. We can take y equals, so here we go, putting it all together. Y equals, and we can have x squared as our basis. Now let's put in multiplying it by some factor out in front, which could be positive or negative, greater than 1, equal to 1, less than 1. And then we could introduce our h friend here, like this, and we can add on this. And in that manner, all of our possible transformation processes are combined into one single form of our quadratic relation. This is called vertex form. And vertex form is a really great form of a quadratic to be able to see a lot of information about it just by looking at the values of a, h, and k. What is also really cool is that if h and k move y equals x squared left and right or up and down, we know that the origin for, or the center for y equals x squared is at 0, 0. And we've learned that this special little part of the parabola, that in this case is a minimum, or if it's upside down is a maximum, is called the vertex. So right now the vertex has coordinates of 0, 0. But if we take that vertex or the whole parabola and move it left or right or up and down, that actually means that we can know what the vertex of the transformed parabola is simply by looking here and here. What is the value of h and what is the value of k? And those give us the coordinates of the vertex like this. Pow! Blows your mind away. Okay? But you got to be super careful because don't forget that what you see here is actually the opposite of what the true value of h is. Wow, that's hugely consolidative in nature. But let's show you now in this video how to use it to predict what some quadratics are going to look like. So I'm going to do steps 1 through 4 of your investigation for lesson 4.4, and that'll model for you then how to continue onward with it. All right, in steps 1 to 4 of part A, just as a summary, you are given an equation that looks like this. Okay, and you have to plot it in Desmos, and I've put a video up on our lesson plans of how to actually go about doing that. And I want you to also compare it, of course, with your friend on Desmos y equals x squared, so that you have this one and this one up at the same time so you can compare and contrast them. And the idea in this investigation is I want you to tell me in what ways has this parabola changed, or in what ways does it look different from our base parabola. Now, I want to just talk about this one for a second. If we go to our new form of the equation that combines all those transformations together, and I'm just going to put it back up here for us. There we go. Can we overlap this with this? I'm going to put it underneath so that maybe we can. Well, the value in front of x squared is a. So there it is. And we've got x squared. So if there's nothing in here, that means that this is 0. Or we could just write it as x squared. And then out the back here, we have negative 5. So I'm going to tell you some ways that this one looks different from this one just by looking at the equation. I'm going to tell you that comparatively, they're both upward facing. I know that because they both have positive a values. I'm also going to tell you that this parabola is skinnier than this one. I know that because its a value is greater than 1, which means it's a stretch factor, which means that one is going to be closer to its axis of symmetry than this one's going to be with an a value of 1. There, so I've told you two things. It's going to be upward, it's going to be stretched, and so in that way these are the same. This way they're going to be different, and there's one other difference too. This parabola is going to have a vertex below the x-axis at -0, -5, right? And again, I know that from simply looking at this. So the coordinates of the vertex right here are 0, -5. And I want you to go into Desmos and prove me wrong, okay? Show me that it's not 0, 5, whereas this one has a vertex at 0, 0, okay? So again, both are upward because of the signs of a. This one's stretched compared to this one. It has an a factor of 2. And another way that they're different is that their vertex has, or their vertices are different. Okay, this one's 0, 0, this one's 0, -5. Bam. And that's how you compare and contrast them. Let's play this game one more time before I let you go and try it. In step 4, it says to make a prediction just like I did if you are given this equation. All right, so how can we overlap this with our general formula to make those predictions? Okay, and again, we're comparing this baby to y equals x squared, okay, our base parabola. So how does this fit? Well, don't forget, our base equation has an a value. It has some value that I can add or take away from x before squaring it. We made that one green up here before. And then it also might have something out here. Okay, so what are those values? Well, looks like the a value for this one is 0.5. Okay, and it looks like there's nothing in here, so again, no change. Okay, and we got a +1 out here. So when I compare and contrast these two equations, this one with my good friend up here, how are they similar? How are they different? Okay, well, they both have a values that are positive. Okay, so they are both upward facing, but they have different a values. this one is less than 1. Therefore, it's compressed. It's going to be wider than my y equals x squared friend, or wider we call compressed, has a compression factor of 1/2 or 0.5. Okay, so that takes care of how A would make it different. No shift left or right, so I'm going to expect the vertex to actually be at x equals 0, but I notice that it's going up or down. It's moved up. And so I'm going to notice that the vertex is at 0, 1, whereas the vertex of the base parabola is going to be 0, 0. So I'm going to expect this parabola to sit above my other one. And if I were to rough sketch this out a little bit, just based on the things I've told you, I'm going to make a prediction that they kind of compare something like this. Let's let my y equals x squared friend look something like this, just to give us a baseline of somewhere to go. This one is going to be wider and still upright, so maybe something that looks like this, okay, is where I would start. But I forgot to take into account that the vertex is going to be moved up a little bit. So I'm going to move it up to 0, 1, and it's going to be wider. Okay, and this should be what that parabola looks like compared to our base parabola of y equals x squared. And I encourage you, go on Desmos and punch them in, because that's the easiest way to do it, and see if your prediction is right. All right, hopefully that gets you started with 4.4. There's a lot to chew through, because you got to know all those transformation factors and what they do before you start combining more than one of them at a time. So make sure you're solid with 4.3 before you move on to 4.4.